Hi everyone, today we are going to continue our conversation about functions and speak specifically about linear functions. So last time we talked about how a function is a special rule or equation that tells you the relationship between x and y, where there is just one output for each input so that it's a reliable rule. Today we're talking about linear functions. Linear functions are just functions that can be written in this specific form of y equals mx plus b. And m and b are both constants. So what that means is that they represent numbers. So you can have an equation that looks like this, for instance. So m and b are specifically numbers that can be replaced there. Okay, and the function y equals mx plus b is called a linear function because the powers of x and y are equal to 1. So if you notice, there's no power there's no power written here, so we can assume that it is to the power of 1. Okay, when we talked about quadratic equations, and later we'll talk about quadratic functions, you notice that there was a power of 2 or squared, right? So when you see that there's, quote, no power, it really means it's a power of 1, and it is a linear function. What do we mean by linear? Well, we just mean that if you were to graph the function, it is going to create a straight line. And we actually have talked about a linear function before, actually in our last video. The example we worked on, we ended up with the equation y equals 20 plus 10x, which is in y equals mx plus b form. I can rewrite it as y equals 10x plus 20. And so this would be in y equals mx plus b form. There is a number that's being multiplied by my x. In this situation, it's 10. That's my m. And there is a number being added to in the beginning or the end, depending on how you write it. That's my b. So that is also in y equals mx plus b form. So in the last video, the example we worked on, that equation was in y equals mx plus b form. It was a linear function because look at that. When we graphed it, it was a straight line. And the powers are all equal to 1. So this right here is an example of a linear function. Okay, so let's go back and talk about y equals mx plus b, because you're thinking probably, what are m and b, right? Other than the fact that they go into my equation. Like, what do they actually mean? What's so special about them? Well, in order to answer that question, I'm going to have us take a look at some example graphs. So let's do some investigation of m and b. I opened up a page on Desmos using their graphing calculator, and I've created a whole bunch of different equations. They're all written in y equals mx plus b form. They all have y equals, they all have a number being multiplied by x, and they're all adding or subtracting a number at the end. Okay, so we're going to take a look at them and investigate what exactly m and b are. So I'm going to show equation 1, 2, 3, and 4 here. They all have the same m, the same number being multiplied by x, but they have different b's, the number that being added at the end. So we're going to show them to see what maybe the b is. Okay, so these are all different equations that have different b's. This b is equal to 2. This b is equal to 4. This b is equal to -1. And then this last b is equal to 0. So go ahead and pause the video and see what you think b possibly could indicate in these equations and graphs. If you noticed that the b value basically tells you where it touches the y-axis, then you are correct. That's all that is. Your b value at the end basically tells you where your graph starts. So for the red graph equation here, y equals 1x plus 2, if you notice it starts at 2 for the y-axis. For the blue line, it starts at 4 because it was plus 4. For the green line, it starts at -1 down here because it's -1. For the purple line, it starts at 0 because it is plus 0. So your b value basically tells you the starting point on the y-axis. So basically where it touches the y-axis. Now, if we were to revisit that problem from our last video, you'll notice, hey, look, this was the b here. Let me rewrite it in our y equals mx plus b form. Our b was that 20, and that was our starting point, right? Because that's the starting temperature of our water before we even started heating it, was the 20 degrees Celsius, and the equation showed plus 20. So it all matches up. And look at that, in my graph, it's where the starting point is on my y-axis. My graph started at 20. All right, let's take a look at some different equations now. So before we were looking at different b values, and now we want to take a look at different m values. So remember, m is the number that's being multiplied by your x. So now I'm going to show a bunch of different equations with different m values. I'm going to keep the b value, the starting points, the same so that we can really see what's going on with our different m values. All right, here's the first one. Y equals 1x plus 0. Starting at the 0 for the y-axis, that's our purple line. Now this black line is with the m value of 2/3. So you'll notice that the m value of 1 was a little more steep. The m value of 2/3 was less steep. If you look at how the graph is increasing. Now if we compare the m value of 1 to now the m value of 5, whoo, look how steep that is, climbing up really quickly. So really what it's changing is how steep the line is. So your m is how steep the line is. It tells you the steepness of the line. It is called the slope. M is the slope. That's the mathematical term for the calculation for how steep a line is. We also call it the rate of change. So it's basically how steep the line is telling us how fast it's changing, the rate of change. Like for this slope of 5, it's changing really quickly, right? It's super steep. For the slope of 2/3, not changing as quickly. It's not climbing as quickly. It's not as steep. The slope is lower. Okay? Now, you're probably also thinking to yourself, where did they get the 1? Where did they get the 2/3? Where did they get the 5? So we can calculate the slope or the rate of change using the formula for slope, which is rise over run. So the actual value for slope is based on this formula, rise over run. Let's take a look at just the purple line, the original line, where we have a slope of 1. Where did we get that 1 from? Well, let's choose two different points on this line. If the slope is rise over run, then we are basically trying to calculate how many steps it takes to go up, connecting these 2 points, and then over, connecting these 2 points. So sometimes you'll see people drawing a triangle connecting them. So this point starting down here is going from the value of 1 to 2. So it's going up 1. Now it's over here going from 1 to 2 on the x-axis. So its slope is a rise of 1 and a run of 1. 1 divided by 1 is 1. That's how we get this slope equals 1. I can choose any 2 points. I can choose starting here and going over here. It's a bigger triangle. It's going to be different values for rise over run, but it's still going to give you the same answer of slope equals 1. So if I start here, starting from 3, jumping up to 4, and then 5, I went plus 2. 3 plus 2 gets me to 5. Now I'm here looking at my y or my x values. I'm starting at 3. I'm jumping 1, 2, plus 2 to get to 5. Different values. Now I have 2 for my rise over 2 for my run. Still divides to equal 1. So that's where we get our calculation of 1 in our graph and in our equation of 1. Okay, let's try a different slope. Let's try this slope, 2/3. Again, I'm going to pick 2 points. This point here, and how about this point over here? So I'm going to draw myself a triangle to kind of map out my path. Starting at 0, going up 1 and 2. 0 plus 2 gets me to 2. And now back at 0. 0 plus 1, 2, 3 gets me to this 3. That's how I get my m of 2/3, because it's my rise over my run. I can invert that. Let me use a different color. I can start from this top point to go down to this first point that I started off originally. If I'm going down, and this is why we usually don't go in this direction, we always build up, because now you have to deal with negative numbers. Now I'm starting at 2, I'm going down, 1, 2, 2 minus 2 gets me back to this 0 here, -2. And now I'm here in this corner. Now 3 has to minus 1, 2, 3 to get to this 0. So I still get rise over run with 2's and 3's, but now they're negative. Negatives cancel out to get 2/3. So that's why usually people like to build their rise over run going up rather than going down, to avoid those negatives, because they eventually cancel out anyways. Okay, so that's why this calculation for slope for this line is 2/3, because we're talking about how fast it is rising versus how fast it is running. That'll give us a calculation for slope. Similarly, for this y equals 5x line, I can choose 2 points. They're going to be further away from each other. Skinny long triangle. I'm climbing up 1, 2, 3, 4, 5, plus 5. 0 plus 5 to get to 5. 0 plus 1 to get to this 1. So then this slope is rise of 5 over run of 1. So it ends up being a slope of 5. This is a really steep slope, because we are going up, rising so many steps before we run just 1 point over. Okay, so the bigger your number is, the steeper your line is. Now let's take a look at, let's compare the slope of 1 to the slope of -1. What do you notice? This line is going in the opposite direction now, right? And it's a negative slope. So if I were to calculate the slope here, going up 1 to get from 1 to 2, and going backwards from -1 to -2, I'm going to subtract 1. So now my slope is +1 over -1, which is -1. My negative slopes are the ones that are going to be going in reverse. Instead of increasing, we are now decreasing. So here are all my negatives. If you notice, they are going in reverse direction now. It is a decreasing slope, my negatives, because one jumps up, but the other one jumps backwards. Okay, so then back to your notes. What are M and B? The M is your slope, tells you how steep a line is, and then your B is the starting point. Okay, the slope is the rate of change. Tells you how much is changing each time. So if we look back at, again, the example from our previous video, we can also find that rate of change in our equation. We scroll back to that. This was the one with the temperature in the water, right? Starting point was 20 because the water started off with 20 degrees at 20 degrees Celsius. And each minute that passed, it went up 10 degrees Celsius because it went, well, we skipped some numbers in our tables, but it did go up by 10 each time, right? 5, 70, 7 is 90, goes up by 10 each time. In our table, we also saw, or we can find, that it's going up by 10 each time. Let's just figure out the slope here. So this is going up from 60 to 80, so that slope is plus 20. And then going sideways, it's 4 to 6, so that's going up 2. So our slope, rise was 20, run was 2. 20 divided by 2 is 10. 20 divided by 2 was 10. So then that's how it makes sense that our slope was also 10. 10 in our graph, and also 10 that's being added each time in our table. So here is just a summary of what we talked about. The slope of a straight line is measure of its steepness. If you don't have this in your notes yet, please make sure it goes in your notes. Very important word. Slope of a straight line is a measure of its steepness. So we use the measurement of how it rises vertically per unit length compared to how it rises or changes horizontally. So rise over run, vertical change over horizontal change. We have lines going this way, positive slopes, a positive M value. We consider that increasing. And then we have negative M value, the slope would be decreasing. So then, for example, the y coordinate, no matter what that is, you would take a look at whether it's going upwards or starting with your y coordinate, your y-intercept, if it's going downwards, okay? The b value is your y-intercept, and that tells you where the starting point is, the point of intersection on your y-axis. That's called the y-intercept. That's your b value. Y-intercept. It's kind of like in football where it intercepts or touches the y-axis. Okay, so in summary, the graph of the linear function y equals mx plus b in that format would create a straight line where the m value is your slope, telling you how steep your line is, and the y-intercept, your b value that we talked about, is the starting point where it touches your y-axis. So if we had to graph y equals negative 7x plus 6, we would get a straight line. It would have a slope of negative 7. So I'm assuming then that means my line would be going like this. Oh, and it's a negative because it's negative. It's going downwards, decreasing. It's a -7. It's a big number, so I would imagine it would be a very steep line. And the y-intercept is at 6, so that means that it would touch the y-axis at 6. Okay? All right, so let's check it out. I have y equals -7x plus 6. Let's graph it. Yeah, it's a steep line. It is decreasing. It is starting at this y value of 6 for my y-axis. So using my m and b knowledge, I can now predict what the graph of a linear function would look like just by looking at the equation. It's pretty cool.